Hello friends, I welcome you in lecture number 2 on wave equation. In lecture number 1, we have discussed the solution of wave equation satisfying given boundary and initial conditions. And we just recall that solution which we have derived in lecture number 1. We have seen that if we have wave equation del square u by del t square equal to c square times del square u by del x square, then it represents the mathematical model of vibrating string, and the solution of this wave equation satisfying the boundary conditions u0 t equal to 0, ul t equal to 0 for all values of t, and initial conditions say ux0 equal to fx and del u by del t at t equal to 0 is gx. This is the wave equation with these two boundary conditions and these two initial conditions, and we have discussed in lecture number 1 that the solution of this boundary value problem is given by uxt equal to sigma n equal to 1 to infinity bn cosine of lambda n t plus bn star sine of lambda n t, this into the bracket times sine n pi x over L, where this lambda n are nothing but eigenvalues given by c n pi over L, and n is from 1 to 3 and so on. And this bn and bn star are given by this formula. Bn is given by 2 by L integral 0 to L fx multiplied with sin n pi x over L dx. This fx is the initial deflection, and this initial velocity gx is used to find out value of bn star, and bn star is given by 2 divided by c times n into pi integral of function gx multiplied with sin n pi x over L dx. This we have to remember every time. We will not use method of separation of variables to derive this solution, but we can easily remember this solution, and all we have to decide is this lambda n, bn and bn star. Before that, we have to compare given conditions in given problem with this standard form, and we have to decide what is fx and gx for the given problem. And here we can see that given equation is utt equal to c square uxx, that is wave equation, and length of the string is L. Boundary conditions are u has 0 value at x equal to 0 and x at x equal to L, and del u by del t at x0 initial velocity, I have made a mistake here. Initial velocity is given to be 0, and initial deflection is given by ux0 equal to pi x divided by L, and this is when x lies in between 0 and L, and initial velocity is 0. So if we compare these initial conditions, initial deflection we had taken as ux0 equal to fx. So if I compare this with this standard form which we had taken in lecture number 1, then we find that fx is equal to pi x divided by L, and initial condition was considered as del u by del t at t equal to 0 equal to gx. So if we compare this with this one, we find that function gx is 0, and C is as it is. C is the physical constant, that we will keep as it is. L is also as it is, and we will consider fx equal to pi x divided by L. So first you have to decide what is fx and what is gx. So here I write that in given problem we are given that initial deflection is equal to pi x by L and initial velocity is given as 0. Therefore we will consider f of x, which is initial deflection, is pi x by L, and gx is initial velocity, which is 0. Now lambda n is Cn pi divided by L, n equal to 1, 2, 3 and so on. And first we decide what is Bn. Bn is given by 2 by L integral 0 to L f of x times sin n pi x divided by L integral with respect to x. This is equal to 2 by L integral from 0 to L. Fx is pi x divided by L, that we substitute here, pi x divided by L times sin n pi x divided by L integral with respect to x. Now to integrate this product, we can see this is product of two functions, pi x by L and sin n pi x by L. To integrate this, we use integration by parts. We use general rule of integration by parts. So we consider u equal to pi x by L and v equal to sin n pi x by L. So first we will start with u as it is, then integration of v, then negative sign, derivative of u and integration of v second time, and we will continue in this way. But here we can see that first derivative of u will be pi divided by L and second derivative will be 0. So we will have finite number of terms in the integration or in the answer of integration. So here first I write 2 by L as it is. We first keep u as it is, that is pi x by L. We integrate sin n pi x by L with respect to x. So integration of sin n pi x by L is minus cosine of n pi x by L divided by coefficient of x, which is n pi over L, minus derivative of u. So derivative of pi x by L is pi divided by L, and integration of v1. This is u, this is v1, this is u dash, and here I have to write v2, that is integration of this bracket. Integral of cos function is sine function, this negative sign as it is. Here I will write minus sin n pi x over L divided by n pi over L, and there is 1 n pi over L here. So here I will have n square pi square divided by L square, and limits of integration are from x equal to 0 to x equal to L. So this we have written using general rule of integration by parts. Now we try to substitute values of x. First we put upper limit and then we will put lower limit. And if I put upper limit, before putting upper limit I can see that this pi over L will get cancelled, and if I take this x equal to L here, this L will get cancelled and I will have minus cos n pi divided by n. And if I take x equal to L here, I will have sin n pi, and we know that sin n pi is 0 if n is integer, and here n is starting from 1 to infinity, that is n is a positive integer. Therefore this sin n pi will be 0 for x equal to L. So for upper limit we will obtain only this part, that minus cos n pi divided by n. If I take x equal to L, this L will get cancelled, and here I am left with minus cos n pi, and there is n in the denominator. This is for upper limit. And for lower limit we can see that if I take x equal to 0, then here x is in the product, so this term will become 0 when we take x equal to 0. And if I put x equal to 0 here, I will have sin 0, so that will make this term 0. So there is no contribution from x equal to 0. And this we can rewrite as minus 2 by n pi into L, and cos n pi is minus 1 raised to n. And this I can rewrite as, here I have to write minus 2 by n into capital L into minus 1 raised to n, and this minus 1 I can combine with this minus 1. So minus 1 raised to n into minus 1, that is minus 1 raised to n plus 1. And here for upper limit, when I take x equal to L, here I will put x equal to L, and here also I have to take x equal to L. So there is one L here. So that L will get cancelled with this L. So I don't have to write L here. This is minus 2 by n minus 1 raised to n, or we can say that minus 1 raised to n plus 1 into 2 by n. This is my Bn. Therefore Bn becomes 2 by n times minus 1 raised to n plus 1, n equal to 1, 2, 3 and so on. So be careful when you are putting limits. You have to take care that when I take x equal to L, then I have to put x equal to L everywhere where I find x. So I forget to put x here earlier, but if we take x equal to L here, then here I will have L into minus cos n pi divided by n, and that L will get cancelled with this L. So this is my Bn. Now what is Bn star? Bn star is given by 2 divided by Cn pi integral of function gx multiplied with sin n pi x over L dx. But here gx is 0, therefore Bn star is 0 for all n. Bn star equal to 0 for every natural number n. Now once we obtain Bn and Bn star, we can put their values in the formula of the solution of wave equation, and we have our solution satisfying given conditions. So in the next step we write down that formula of wave equation. So now the solution of wave equation is given by uxt equal to sigma n equal to 1 to infinity Bn cos lambda nt plus Bn star sin lambda nt multiplied with sin n pi x over L. We have obtained Bn. Bn star is 0, so this term will get cancelled, and this is sigma n equal to 1 to infinity. Our Bn is 2 by n minus 1 raised to n plus 1, that I substitute here. 2 by n minus 1 raised to n plus 1. What is lambda n? Lambda n is Cn pi over L, that also I substitute here. So I will have Cn pi t over L and multiplied with sin n pi x by L, because here Bn star is 0, and here 2 is independent of summation, so that we can write outside summation. Rest of the things depend on n, so that I have to write inside summation minus 1 raised to n plus 1 over n cosine of Cn pi t divided by L into sin n pi x divided by L, and this is the solution of given problem satisfying given boundary and initial conditions, and this is valid for all values of x between 0 and L and for all values of t which are non-negative. So in this way we can easily find the solution of the problem which is having wave equation with this type of boundary conditions and with this type of initial conditions. All we have to remember is this formula of wave equation satisfying this boundary and these initial conditions. So this is all about this session. Keep watching. We will be discussing more problems of this type in upcoming lectures. Thanks for watching.